Hello again, you sick, twisted weather freaks, and welcome to another fun-filled, action-packed, and intellectually stimulating edition of This Week in Weather. I'm your host and meteorologist DT from weatherist.com, the commander of chaos, the colonel of confusion, the captain of catastrophe. Let's talk about this week in weather. And we have a lot to talk about here, a lot of different pot things going on. Our topics, well, let me first, before we get to that, let's show you my picture of my smiling face from Richmond, Virginia. And you can see here I am my Verizon email, my Gmail. There's the Twitter page. There's a Facebook page. So, all right, our topics here. Couple of things to talk about here. A lot of useful meteorology to discuss and show and analyze. Seasonal trends. We want to talk about that. That's always an important trend. You know why seasonal trends are important. People overlook them, and whenever you look at what should produce this or should produce that type of weather patterns, you always have to modify depending on the seasonal trend. So then, of course, the seasonal trend is dominated by the La Nina. So, and then once we figure that out, then we'll take a look at the second half of January and February and see where we're going with there. So let's begin by taking a look at some recent events here. Now, this is the one from January 7th. And initially, this data here is from, January 5 and 6. You can see this is the high-resolution short-range Canadian model, which showed a large upper low. I talked about this in the last week's video, but you can see it right here. And then it remained a closed upper low as it moved to the east. And if it stayed that way, it would produce an area of decent snow in North Carolina and Virginia. And instead, what happened is, of course, we now know that it did this. The upper low opened up, and this piece of energy here, there's the upper low right there. You see that? That was the upper low right there. Okay. And then this piece of energy here these were going to rip off the top of this system, so it would collapse and we would not get any snow north of the Virginia-North Carolina border. Now, the models were showing some snow into much of central and eastern Virginia, but that did not happen. And again, you can even see the Canadian there showing a decent snowstorm halfway up the Shenandoah Valley, a few inches in Richmond, some out by Lynchburg, so on and so forth. None of that happened. There was, we know what happened. We were in northwest North Carolina, got a little bit of snow, in southwest Virginia, but it was not a big deal. European also was very bullish with it. A nice conglomeration, low pressure area along the North Carolina coast, which typically brings decent snow to northwest North Carolina and a good portion of Virginia. That was the European Ensemble. Not showing a huge event, but showing something. And that did not happen. Now, one of the reasons why that did not happen was because of this howling jet stream, which is a problem, La Nina. And that's one of the reasons why we ended up with such a crappy overall pattern. So let me see here, and this is the one for January 12th. We'll get to the second. But this howling jet stream was coming in from the Pacific Ocean. It's been a constant problem, and this is very, very typical of La Nina. Very enhanced, very strong, persistent Pacific jet stream. And what it does is the energy is so strong, the northern, instead of the northern system phasing with the southern systems, which is how you get your big winter storms, it crushes the southern system, or it rips the top of it off. And we'll see how that happens in just a second. So there's another example of this. This happened just a couple of days ago. This is today's. If you recall, this is from January 6th. The models were forecasting a decent sized East Coast low with some snow running from the Carolinas and Virginia up into New England. And this is the jet stream map, 150 hours valid for this Tuesday morning. Now, you can see the very strong jet streaks here. So let's take a look at that. You see the purple and the red here? Very impressive. Now, this one moving off the East Coast. There you go. Right in that area. That is, 130 to 150 knots at 250 millibars. And then look at now coming into the Pacific, it was wind, pretty good winds here, with the good velocities here, around 100 knots, but not that strong. And then you have this enormous blast. Look at this stuff. This amazing pink, what is it? 200 knots. Can you believe that? 200 knots. The model was forecasting the GFS on January 6th, valid for January 12th. But because the winds here coming into the west coast were not that strong, the models are forecasting this low developing and getting some kind of winter precipitation. Let me show you what I'm talking about. Now this was the, again, this is January 6th. So we saw the upper air pattern, and this is the 500 millibar on the surface map. So we had this moderate low along the coast. You can see it here. Not a big system, but something. And then you had a closed upper low right here over, I guess, the Arkansas, Missouri border. And a nice big general broad trough like this. You can see, follow the lines very closely. Nice big trough right there. That did not happen. Why did that not happen? Well, look, that was January 6th, valid for January 12th. Then, this is the new stuff. This is January 10th, also valid for January 12th. Look at the difference between this and that in 48 hours. And that's a huge difference. That is a big difference. And one of the reasons why we saw that, and look what happens here. The northern jet, like I just said, comes ripping in and crushes this southern system completely. So you just get a little shear axis right here, just rips the top of it right off. And if we look at the jet stream again on the upper air maps, this is January 10th, valid for January 12th. Now look at the strong winds coming into the eastern Pacific. Much stronger than forecasted right here. So let's compare this image. Oops, let's go back to, where was it here? This is, okay, that was January 6th or January 12th, and compare that to this. See the difference? See how much stronger the winds are coming into the Pacific Northwest? Much, much stronger. And that means how that really destroys the whole pattern. You can't get a ridge on the West Coast. You can't get any pattern amplification. And sure enough, the whole system is just, just gone. And we can also see that here. This is January 12th. Today, you can see, and even the winds are even stronger. Compare that to this. And if you want to verify, this was January 6th. Look at the winds in the Eastern Pacific specifically coming into the West Coast of North America and compare it to that. Much stronger. So this is the effect of the La Nina. So it's a seasonal trend. What it means is that you're going to have the consistent La Nina until it begins to weaken. Now, I don't know when that's going to happen. I think it's going to happen late January, February, but I don't know. Who knows how long it's going to last? The howling Pacific jet stream, as long as that's a problem, as long as that remains strong, it's going to be a problem for the forecast in terms of getting accuracy in the extended weather models. Now, what the La Nina does is it constantly brings in a lot of systems and prevents any of them from developing. So that's one of the reasons why with La Ninas, you don't get a lot of big East Coast snowstorms. Now, with weak La Ninas, it's a little different, but not with the moderate ones. You just don't get them strong ones. You never get them. Because the northern jet is so strong, you can't get the northern jet and the southern jet to phase. And it's that phasing is what produces your big East Coast winter storms, or the Appalachian storms, or the Ohio Valley storms, or what have you. All right, let's take a look at our teleconnections here. So ideally, I've pointed this out before, to get a good, significant East Coast snowstorm, a SEX or MEX, which is major East Coast snowstorm, or a HEX, which is historical East Coast snowstorm, you need to get certain patterns in your teleconnection set just right. So in the Pacific, you want to see the negative EPO and a positive PNA. So, and this map is set for like this. There's your positive PNA, there's your negative EPO. You want to get negative Arctic oscillation and a negative NAO. So that's what you want to see. Okay, that's your classic jet stream map showing, potential snowstorm down the road, assuming, of course, your temperatures are cold enough. Now let's take a look at the charts and see what we're showing. Now we're seeing much better agreement here. Last week we had the GFS operational was doing something funny with the NAO and the Arctic oscillation. It's not doing it now. So this here is the Arctic oscillation right there. Notice here we are, and all for the next 2 weeks it's strongly negative. Way down here, all the way to the end of the month. See that? And this here is the NAO right here. And you can see there it is. It drops negative, 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 and then really negative. It might come up a little bit towards the end, but it's strongly negative for the end of the month as well. Okay, that's good. That's half of what we want to see. Negative Arctic oscillation, negative NAO. So far, so good. Now let's go to the Pacific side. Here is the EPO. Now the EPO, again, that's when your ridge is in Alaska and extends up into the Arctic Circle, which is what pulls down your Siberian air, your cross-polar flow. So that's why you want to see this going negative. Sure enough, now here we are, but what happens is January 12th, or positive, it drops down, then pops up, and then it's on a general negative trend. See that? And by the time we get to the January 20th, it goes strongly negative on most of the models. Now, the PNA pattern, which is the original West Coast, we have that, but that does turn negative as well. So that's not good. This one here is not good for East Coast snowstorms. That means you're getting a trough on the West Coast, but you have strong ridging in Alaska. Now, so what does that mean? Yeah, how can you not, well, it's called a split flow pattern. That's what that is. It's a split flow pattern, and we'll get to that in just a second. Now, to get to that event, we have other things to talk about first. So this here is the first Arctic outbreak. Now we can see a lot of stuff here. This is valid this Friday. Here's our big low north of Chicago in Wisconsin. A blizzard potentially in Iowa and Minnesota, maybe the eastern Dakotas, northeast Nebraska. And there's our strong cold front. We have warm air coming up ahead of the front on Thursday, Friday, and then strong howling winds bringing the cold air in. All right, well, that's not a surprise. And the reason for that is because of this. Look at that monster trough and a huge upper low. Classic Midwest blizzard. For some areas, of course. Not the Ohio Valley, mostly upper Mississippi Valley. Like I said, Minnesota, Wisconsin, Iowa, the eastern Dakotas, northeast Nebraska. Then after that reaches the East Coast. This is now Saturday morning, so there's a little bit of a low on the front, but the main front is like this, and the other low is hanging back here, and you're getting snow squalls here, and rain on the East Coast, some snow in the mountains, blah blah blah. Typical cold front passage. Then after that happens, this is January 18th on next Monday, and we have a reinforcing trough, a shortwave coming through, which brings in another cold front here and another one there. So, we're having these waves of fronts coming through, reinforcing the cold air, and the temperatures do continuously drop. Now, that being said, here's our next really uncertainty. This is the early morning European model, the operational run. No, actually, I think this is the ensemble. Excuse me. This is the ensemble from early Tuesday morning. Now, I posted this earlier on the Twitter page and on the Facebook page. So let's take a look at it. We have our big blocking here, our negative NAO, monster block in Greenland, classic block, and the strong ridge here on the West Coast. But the ridge is not really on the West Coast. It's in the Eastern Pacific. See that? It's here. It's off coast. So as a result, you end up getting a bit of a trough on the West Coast, which is a negative PNA, right? But look at the ridge developing in Alaska, pushing into the Arctic region. So that is a negative EPO. When the ridge builds like that, that's what you want to see. So as a result, you end up with a split flow. You have one jet stream doing this, and you have the other jet stream doing this. Classic split flow. Let me highlight that again so you can see it. The northern jet is doing this, bringing the cold air in, and here's the southern jet doing that. Classic split flow. Now, if the two jet streams phase the right way, you get a snowstorm or a winter storm. The problem is there's so much damn energy in the northern jet because of La Nina, it may not happen. And sure enough, that is the issue. That's like I said, we don't know if it's going to happen. If the two jet streams phase, yeah, but we don't know that. Now, this here is the 12Z run. To Tuesday here, the operationally European of both these models. We can see clearly what happens. There's the southern system. Here's our split flow. There's a northern jet. There's your southern jet. Here's our 50-50 low. There's a block. I mean, this is screaming big winter storm. The problem is that this piece of energy here in the Pacific Northwest races into the plain states, and these two systems are interacting. Now, does it get crushed? Does it? Do they phase? What happens? I don't know. The models often have the tendency of crushing the systems too rapidly, but look at that enormous 50-50 low over New Brunswick and Maine. That's kind of far to the south. So if this system does produce low pressure, you're not going to get any precipitation north, let's say Richmond or DC or Charlottesville, if that happens. And indeed, that's sort of what the model is showing. Here's the operational run. It gets up to the Virginia-North Carolina border. Nice snowstorm for North Carolina and Tennessee. Yay for those guys. North of the Virginia-North Carolina border, not happening. And you can see the huge ocean low off the map here. The big ocean low is here. And look at these winds, howling north winds. Look at these winds bringing down the cold air. Yeah, that is cold air, folks. That's due north winds pulling the stuff down. Okay, and there's your front like that. So there's a lot of cold air coming in, but we'll see how far this system develops. It's possible it could come a little further north or further south. I don't know. It's just something to watch. All right, now let's go beyond this. Let's talk about what happens after this. Here's January 22nd, moving beyond that time frame. So this is the EPS from this morning, early on Tuesday morning. And what we see here is the block in Greenland here is pushing northwest towards the North Pole, really, towards Baffin Island, the big island north of Hudson's Bay. And here's the ridge in the Gulf of Alaska, the negative EPO pushing into the Arctic regions. So by the time we get to January 24th, we have what's known as linkage. That is to say, these features have become one giant massive block, and that forces a broad trough southward and bring in the cold air. The polar vortex comes forced way south. You see what the polar vortex is here, folks? Way south, driving the cold air southward, even though you have zonal flow. See this? The flow is still essentially west to east. You're not getting in this flow, you're not getting a dramatic Arctic outbreak coming southward. You're getting essentially a Pacific jet. The Arctic flow is here. There is Arctic air coming southward along the U.S.-Canada border. But the southern jet is doing this. The result is overrunning. The front comes fairly far to the south, then it stops. There's a lot of deep Arctic air north of the front, and you get waves of low pressure forming on the front, and you get your ice and snow that way. This is one of the only ways you can get a good winter pattern when you have a moderate or strong La Nina. This is the only way you can do it. When you have to get both ridges, the Gulf of Alaska ridge, Alaska, and the block over Greenland to wham! Meet over the North Arctic regions and push everything to the south. This is what it looks like at the surface. Hang on a second, clear it out. Oops. There you go. Now, this is the GFS Ensemble. It shows the same general thing. There are a few minor details, but we're dealing 10, 12 days out. Again, both models have a big ocean low. You see this right here, right there. You see that there. Okay, that's on the previous model as well. Look at the enormous high, 1045 millibars up in northwest Canada. See that? And then sending down baby highs, 1035, 1040, coming southward. Both models have the polar vortex. You can clearly see that. And look how far the south to the front goes. So now here, meanwhile, you're still getting your Pacific jet enhanced by the La Nina, bringing in energy to California, moving right across the country in a west to east direction at a fairly far south latitude. This is overrunning. This here is the European Ensemble, day 10 from early this morning, showing the same sort of thing, the service map. It matches this map here on the left-hand side, but this is the service map. Different model. This is from Storm Vista. The other one's from Pivotal Weather, but it's the same sort of thing. Big, giant Arctic high to the north, the front coming far to the south, and you can see these disturbances in the pieces of energy. One here, one here, one here, which is going to, potentially make, overrunning snows. Again, notice the big upper low, big giant ocean low here off of Newfoundland, Canada. And because of this system here, and because of the block, when you get energy coming into the west coast, normally your ridge goes up. When you have a trough here, you often get a ridge in the southeastern states, right? That's what often happens. But here, because you have a huge block in Greenland, and a giant low off of Newfoundland, Canada, the 50-50 low, the pattern remains flat. So the cold air comes southward, and your Pacific energy runs into the cold air, and you get your snow and ice. Let me show you what I'm talking about. Let's take a look at these temperatures. Look how they crash. This is January 22nd, January 27th. See the difference? Coming way far to the south. You see the green lines, which are mild air at 850, come disappear, go push way to the south. See that? That's what I'm talking about. Now, it is true, the heart of the Arctic air is in Western Canada, headed towards maybe the Pacific Northwest or the upper plains and that sort of stuff. But that doesn't mean there's no cold air in the Northeast or the Mid-Atlantic or the Ohio Valley or the Midwest. That's kind of a mistake for people saying that. And if we go beyond that, this is the GFS January 25. Again, notice the enormous Arctic high here, 1050 millibars in northwest Canada. And there's another high here coming down from it. Look at the north winds evecting the cold air from the ocean low. Strong north winds in New England. Okay, and there's a disturbance here, and there's a stalled front here. I'm telling you, this, folks, has potential all over the place if this is correct. And this is just overrunning. Notice no big low pressure systems anywhere in these maps. No coastal storms, none of that. See? Again, that's the only way it happens in La Nina patterns. Now here is the European precipitation map. This is for 246 hours out, which is January 22nd and January 27th. You can see along the front here, some of this is snow and ice. And then here on January 27th, with those cold temperatures, all this is snow and ice in here. In a half inch, 3/4 of an inch, that sort of stuff. Just showing up there. And then you can see the temperatures. Look at the temperature anomalies on the GFS. So we saw this. Let's see the GFS and more, we'll focus on a more eastern US. But you can see this here at the top of the next 5 days from January 18th to the 23rd and then January 23rd to the 28th. These are pretty cold temperatures. This is not bad. These are pretty cold temperatures. And that any precipitation in this is all frozen. North of, the southern Gulf Coast. It's all that. And then look at the precipitation here. Okay, coming out on this slug in week 2 along the stalled front. Significant precipitation on GFS Ensemble. A lot of this is snow and ice, folks. If these temperatures are correct, if this is right, that's a pretty big snow and ice event coming. And again, not a giant low pressure area, nothing like that, just overrunning. There we go. I'm pretty positive that this is going to happen. We'll see if it changes, but I'm pretty bullish about this whole thing, I got to tell you. Okay, a longer term, what happens this year is the CFS here takes us into last of January, beginning of February. Now, if you look at this pattern again, this is tricky. You look at this, there's your polar vortex here. There's your block here. Okay, you have your ridge is out here, and the mean trough is over the Rockies and the upper plains. But this is not a warming pattern because you still have this closed 500 low here. So you have a bit of a trough, but there's no ridge on the west southeast coast. Look at these temperatures still. Temperature anomalies. 10 degrees below normal, 8 degrees below normal Fahrenheit, 12 degrees below normal throughout the Midwest and New England, the Mid-Atlantic. This is still a cold pattern going into February. Now, I don't know if this is right, but, this idea that it's going to flip in February, I'm not seeing signs of that. It might flip in the second half of February, but in addition, by the time we get to February, the La Nina might be weakening significantly. That's what most of the data is showing. So that would also allow the colder pattern to last longer into February and or March because La Nina supposedly is going to be weakening at a rapid pace once we get into February and March. Anyway, that's the forecast and the discussion. I hope you enjoyed this video. This is meteorologist DT from Weather Risk. I'll see you on the Twitter page and on the Facebook page.